Every model you see today topping a leaderboard, it's not as good as it looks. Here's why. The benchmarks we use to measure intelligence are static. They were written by humans and hence finite. And the moment a model sees enough internet text that overlaps with them, the scores stop meaning anything at all. The Hugging Face Open LLM leaderboard team documented this publicly that models cluster at the top, the community loses trust, the engineers redesign the entire benchmark by hand, and within a month it saturates again. It's a treadmill with no exit. But that's only half the problem. The other half is that even during training, we don't know what a model actually cannot do. The standard benchmarks measure only known capabilities. They cannot find the blind spots, the reasoning combinations, the compositional edge cases, the failure modes that exist in the model right now, but that no human ever thought to test ever. A model can score 87 on math and yet fail systematically on negation plus arithmetic. No one knows that. There's no tool to find it. So we built Alice. The full form is Adversarial Loop for Intermodal Co-evolutionary Environment. Alice is a reinforcement learning training environment, OpenENV compatible, and plug it into any TRL run that solves both problems simultaneously through a single co-evolutionary mechanism. An Oracle interface queries stronger reference models to find the discrimination zone. Tasks, the reference model passes but your model fails. A hunt agent adversely searches that zone for novel failure modes. A repair agent synthesizes targeted training pairs to fix confirmed failures. A three-tier verifier sandbox programmatic check, training, chain of thought, LM judge, and a regression battery ensures repairs stick together without breaking anything else. The key insight: when the repair loop fixes a failure, the Oracle discrimination reward collapses on the task. It's no longer informative. The benchmark is structurally forced to escalate. The model improves, the benchmark gets harder, and the model improves yet again. It's co-evolutionary, self-sustaining, and there is zero human intervention. Let me show you what this looks like running live. First, we have a landing page which highlights the problems, the solution we came up with. Then the overview where we have a live episode counter ticking up, total rollouts, average reward across the last 80 episodes, and the current difficulty tier. Right now we are at tier 2 of 5 in arithmetic domain. Reward is climbing and that's the model improving. Metric table below is your operational health at a glance. When experimented with Alice shows that the sandbox was holding, there was no reward hacking alerts and the latency was stable. The system alerts panel currently one amber flag. For example, a tier 2 judge came score in above as 0.8 while tier 1 returns 0 on episode 47. This is a potential manipulation at a glance. It has been logged for inspection and training continues, but the trajectory is to be queued for human review later. Bottom table involves live feed of tasks, rewards, and timestamps as episodes are completed. Then we have the training metrics. This is the model learning curve where we are running Quen 2.5 to 1.5 billion instruct. It's small enough to train during a hackathon and shows large enough to real capability gaps, and hence the more higher chance for RL score to be increased. Reward curve top left shows the with cumulative curve represents a general upward trend with variance. This variance is healthy. This means the curriculum is keeping the model in the discrimination zone and not letting it coast. The moment this flattens, Alice escalation mechanism kicks in. Then we have the reward distribution in the top right, shifting rightward across training. This the probability mass is moving away from the zero reward towards the positive range. Then the GRPO distribution. This is the group relative reward spread across rollouts. With each batch, GRPO needs this spread to compute policy gradients without a value model. Wide distribution means the task is still discriminating, and narrow means it's collapsing towards easy. Then finally we have the training loss bottom right should be decreasing towards 0 as expected, and there's a table below which shows the latest episode IDs with task preview, difficulty tier, reward, and timestamps. Then we have the curriculum page. This is the co-evolutionary mechanism made visible. Top panel shows a curriculum heat map. Rows are capability domains: arithmetic, logical inference, symbolic manipulation, factual multi-hop, and compositional language. Columns are difficulty tiers 1 through 5. Cell color rolling accuracy. Green means the model is solving reliably. Amber means we are in the discrimination zone. Red means the model is failing consistently. You only see the amber band because no model is training right now. As the model improves, we can watch those amber cells go green and new amber cells appear one column to the right. The rightward migration is the escalation working. Then in the bottom panel, we have the discrimination zone coverage over time. This line tracks what fraction of the oracle's candidate tasks fall in the informative discrimination band. If this line drops, the benchmark is either saturating or stalling. Then we have the HF spaces and jobs page. Here the table shows every model checkpoint Alice has produced ever, with the model name training episodes trained on success status, and if the repair loop validate on the regression battery. For previously trained jobs, the HF job ID is linked directly to the Hugging Face run. You can click on any job ID and jump straight to the HF spaces log. For full reproducibility, every model artifact is versioned and retrievable. Then we have the failure bank. This is the most important artifact Alice produces. Every row is a capability bug that existed in Quen model before we ran Alice. Domain, the adversarial prompt that triggered the fail, and the model's COT reasoning chain shows exactly where it broke down and the repair status. This is what the hunt agent discovered, not failures on known benchmarks, but unknowns surfaced automatically. Then we have the leaderboard. This is the community layer and the Alice's leaderboard, inspired actually by the OpenLLM leaderboard. But instead of static benchmark scores, every entry is an RL capability score computed live by Alice's verifier stack. You can see the models were trained ranked by the scores. But here's what's new: that submission form at the bottom. Anyone can submit their own model, enter their Huggingface model ID, display name, and the parameter count, and other factors. The Alice pulls the models, runs it through the full hunt and verify pipeline, computes its RL score across all 5 domains, and the slots it into the leaderboard automatically if it's working properly. Currently, it will not work because we need HF credits for the same. And finally, we have the pricing strategy page. It's obvious. For evidence, clearly we didn't just build the theory, we ran it. 5 models through the same Alice environment. The results that stops people of 1.5 billion parameter model outsource our 3 billion parameter model across every single metric. Reward success rate, discrimination coverage, not because it's architecturally smarter, but it's trained for 150 episodes instead of 50. The RL loop produces real capability improvement, not just a benchmark gaming. And the failure bank shows exactly which blind spots were confirmed and eliminated along the way. Failures that no longer existing benchmark had ever surfaced. That's not a side effect. That's the point. As a closing statement, I would say that Alice is open. Anyone can submit their model, paste a Huggingface model ID, and Alice pulls the weight, runs a full hunt and verify pipeline, and the slots the result into the leaderboard automatically. There is no static task set, no ceiling to saturate, and the living standard that gets harder as the field improves, because the model field improving is precisely what forces it to escalate. This is what evaluation should have been from the start: a continuous adversarial mirror. Every model evaluated against the same co-evolutionary standard that keeps getting harder as the field improves. And that's Alice for you. Thank you.